In this video, we will describe how to easily create a web service using composable data flows. Composable data flows are a powerful tool for creating reliable and scalable web services that are infinitely flexible. Web services are fairly important for developing modern applications. A web service is a method of communication between two applications over a network. Typically, web services are designed as a unit of managed code that can be remotely invoked or activated using HTTP requests. Web services are self-contained, modular, distributed, dynamic applications. These are all the same attributes of composable data flows. In fact, composable data flows are effectively web services. Web services, and by extension data flows, provide standardized web protocols to interoperate, communicate, and exchange data. The data source could be a cloud database or any type of data store. In this example, we will simply use a flat file that contains roughly 10 million records of taxi trip data. A web service allows you to expose the functionality of your existing code over the network, and other applications can use the functionality of the web service to communicate with each other and easily share data and services. Therefore, being able to design, deploy, and manage web services is critical for modern data-intensive applications. The web service we want to create is an API endpoint that allows for GET requests of a specified number of rows of New York City taxi trip data. So let's begin by creating a new data flow that will serve as a web service. As I mentioned, we will simply use a CSV flat file that is stored locally. Let me drag onto the canvas both the file reference retriever module and a CSV reader module. These will act as our data source. I will type in the full path and file name into the file reference retriever module. This module essentially retrieves a URI of the file. I can use this URI reference to pipe it into a CSV reader. The CSV reader provides a number of parameters to set. For example, the header row location is simply 0, since the CSV file includes a header row at row 0. The CSV data starts at row number 1, so starting row is set to 1. Because this is a large file, let me look at just the first 10 rows by entering 10 into the ending row parameter. I can also set the delimiter and other parameters, if needed, but I'll leave these as is for now. Let me run this data flow and inspect the results. I can see here a table of 10 rows, as expected, of the NYC taxi trip data. Let me also save the data flow now, so that we are given a data flow ID that we will need to reference for our web service. Now, to create a web service, it is actually fairly easy. All I need are two modules, one for web receive, which will accept the GET request, and one for web send, which will respond back with the requested data. Let me drag in both the web receive and web send modules onto the canvas, and arrange them logically from left to right. Notice that the web receive and send modules are highlighted in orange. That is to signify that they can be externally activated, meaning an external process can trigger this data flow. The web receive module has a number of input parameters. The first one is the method. This can be any set to one of the web methods, such as GET or POST. We will set it to GET. The handle is simple to name for your web service. You can provide any handle you would like. The handle is optional, as you can also utilize the Dataflow ID, as I will show you next. The URI and input is where you specify the web service's URI. The stem of this URI needs to be the composable instance you are on, as well the location of the web activation service. You can click on the README to see what this needs to look like. For me, I'm running composable locally, and so the URI will be my local host composable instance that I can copy and paste from the browser URL field, followed by the rest of the URI that I can copy and paste from the README, followed by the Dataflow app ID. To get a Dataflow ID, I must first save the Dataflow, and a unique ID for the Dataflow is generated. If I wanted to use Dataflow handle I provided in this input, I can simply replace app ID with app handle. Let's skip over the other input parameters for now. They are, for example, used to bring in any data that is sent via a POST request or another method. So far, we have the web receive module listening for a GET request at this URI. When the GET request is made, the data flow is triggered. It will reference this file, read 10 rows, and we can now send this data back as a response. The JSON data format is typically used for web services, and so we can use a table to JSON module to convert the data table output into JSON format. We can then pipe this into the web send result in the response and input parameter. Let's save the data flow and see if we can test it. I'll copy the web service URI and open a different browser, one where I'm not authenticated into Composable, and see what happens. I actually get an error saying user does not have execute permissions for the dataflow resource. That's actually the correct behavior. We want to ensure only authenticate users are able to access our web services. So let's go back and share this dataflow so that we can assign the right permissions on the dataflow. For simplicity, while you normally would not do this in production, but here, let's give everyone access. That means anonymous access where no authentication is provided. After saving the dataflow permissions, we can go back to the other browser tab and try to make another web request. Now, with anonymous access provided, we can see the 10 records returned. We can certainly improve on this dataflow in a number of ways. One way to improve the web service is by allowing for the number of records returned to be based on the user input. We can edit the web service URI to accept parameters in this case. Let's add a records parameters by editing the URI to accept a parameter called records. Now we can use a URI parser module, which will parse out the specified parameter, and pipe the output of this module, which will be the value of the record parameter, into the CSV reader ending row parameter. It's always useful to put in a default value in case the user does not provide any parameter values. So I will put in 10 for the default parameter, which means this module will output 10 in the event that the record parameter is not supplied, and my CSV reader will therefore only read 10 rows. Let's copy the web service URI and see this in action. So, in this browser, we can paste in this URI, and let's put in 2 for the number of records. As expected, we're getting 2 records back. Similarly with 5. If I do not provide any records parameter, I will get 10 records, per the default value specified in the dataflow. Coming back to the dataflow, we can further enhance it in several ways. We can, of course, add any number of parameters to the web service URI and use it in various locations in the dataflow. But let's not do that here. Instead, let's focus on the functionality of the web service. We can, in principle, do any number of calculations on this data before returning it in the response. There's a number of table operators we can use that you can find in the module palette. You can even place some custom R or Python code to analyze the data before returning it. Here, let's simply use the table column reducer module to select a single column to return. For example, let's assume we're only interested in trip distance. We can save the dataflow and go back to another browser and make our web requests. Again, as expected, we get back only the single column result we specified. Finally, it's important to note that Composable makes it easy to also manage your web services. One way it does this is by providing a full run history and audit trail. So I, as the owner of this web service, can, for example, look at past runs to see when each request was made and get additional details on each web request if needed. I hope this video was helpful in demonstrating how you can quickly create web services with data flows. Thanks for watching.